If you talking army better.
Sorry?
Oh, okay, I can hear you.
Yeah, you can hear me, right? Okay, I had some issues while uh, starting the recording, so now it's sorted. Hope everyone can see my screen as well. Yeah. So last class we were seeing the a topic inheritance. So how we can basically create a parent class and then create a child class, and how the child class can uh, inherit the properties or inherit the behaviors or attributes, that is inherit the instance variables or inherit the methods of a parent class. So we had seen one example where I had created a bank account class, and we had some of the instance variables declared like account number, name, current balance, and I had created a I'd created a default constructor bank account, and then there were few methods created like deposit method for depositing the amount in a to your depositing the amount, which basically updates your current balance. And then there was another method to withdraw the amount, where we were basically deducting the amount from the current balance, and another method to get the current balance. And then we had one of the child classes created, savings bank account, which also had one of the methods like set salary account. This method was not declared in the parent class. And then there's another method like is salary account, which basically tells whether this is your salary account or not. So boolean return type basically returns true or false. So since these two methods were defined in the child class, these methods are not available to the parent class. But whatever methods have been defined in the parent class are available in the child class. We created objects. So this was another tester class which we were using to test out, which we were using to create the objects of the parent class and child class and call the respective methods. So we basically created a object of the child class, and we were trying to call the deposit method. See, this deposit method was not created or defined in the child class, but since our child class extends the parent class, extends bank account, that means it inherits these methods as well. So it inherits these methods as well, and that is why these methods are available in the child class as well. So we were able to deposit the amount, withdraw the amount using the child class object, and we were also able to get the current balance using the get current balance method. Then we went ahead and created the object of the parent class, and we tried to access one of the methods which was created in the child class. We saw that this was giving us compile time error. Why? Why? Because this child class method, child class method is not available in the parent class, and child class can inherit the methods of a parent class, but it's not the other way around. So using the object reference of the child class, we were able to call the methods which were defined in the child class itself. And then we also saw one example where we basically created a parent class reference which has a child class object associated with it, and we were able to call the methods of the parent class. So this was the example which we saw in the previous class. So this was inheritance of methods. We basically created methods in parent class, and we tried to inherit those methods in the child class. Now you are also aware about the concept of constructors. So there is this inheritance concept also implies for constructors as well. So we'll see today how we can basically
Later,
apply the, yeah,
can you back to for intelligible? Uh, yes,
yes,
sir.
yes,
Yes, sir.
yeah, yeah,
Yeah. The last line 19. Yeah. Bank account one. Uh,
yes,
yeah. New. Why we using saving account? So I expected bank account, but
yeah. So this is also, so sometimes you might get an objective question as well. So when you create a child class object, your parent class can take the reference. See what it is some kind of like compatible data type, means you can say that bank account means this savings account object, right? It is a type of bank account, means, but if you do it other way around, right? If you do savings bank account reference is equal to new parent class object, then you will get the error. But this way Java allows this kind of references, like parent class reference can be associated with the child class object, but this will always call your parent class methods. See, this was like straightforward, co- creating the object of the child class, and the reference was also of the uh, child class. This was another example where we saw, where we created the object of the parent class, and also the reference was of the parent class. But this was one tricky thing. So sometimes the interviewer might ask you, they these are basically like trick objective questions. So sometimes they might create a parent class reference and try to associate the child class object. They will ask you what will be the output of this, whether this will throw compile time error, or whether which method will be basically called. So you can associate parent class reference with a child class object, and this will basically call the methods which are available in the uh, parent class. So try to see, this is one example which will basically trick most of the candidates in interviews. So this is important example.
Okay.
Yeah. So
Is the bank one? Can you go to the bank?
bank account.
Yeah, bank with uh, the import from I don't know why it doesn't work for me. Is this import is necessary from that?
So is this not working for you?
Yeah, the import method. Let's import that one.
Okay, wait a second. What is this? Okay, let me try to remove this. Okay, it's just, I don't know from where that import thing came, but let me try to run the tester class now.
It's work.
yeah, it will work fine.
Can you try to remove that import statement, the one which was here? I think it got somehow auto imported while coding. It must have been auto imported. I might have just clicked on something. So just remove that import statement. It should work now.
Okay, okay. Yeah, it's moving to working, but
Yeah, yeah,
okay.
yeah. I think that somehow by mistake, means your editor gives you some suggestions while you code, right? So somehow I might have just typed it out.
Okay,
I did not see that import statement unless you told me.
okay. All right.
Okay. So we had seen how we can basically inherit the methods and instance variables. So now we'll see the inheritance concept in constructors. So let's go to the slides. We'll see some slides and then we'll come to the demonstration. So we had seen these slides. So let's see constructors and inheritance. So see, I told you one concept, like at the top of the hierarchy, there is the object class. So even if you do not create an, you don't need to basically create an object class, but Java has its its inbuilt object class, and all the classes that you create or define basically inherit the object class. So whatever methods are inbuilt in the object class are available to the child classes or subchild classes. When I say child class, when I say parent class, that is the super class you create. Means suppose you created some class called bank account, so that is your super class. Then you created some other uh, class like savings bank account. So savings bank account basically extends from your bank account class. So savings bank account is your child class. Now if there is another subclass to this savings account, say you have like state savings bank account or country savings bank account, that means it is a type of savings bank account. So you can say this is a subchild of the parent class or a child of the child class. So you can like create as many classes as descendants. Like there can be one parent class, and then you can like create a multiple child classes of that, and then your child class can have further child classes. So that is possible. So let's see this example. This is there's a class object, and this is object constructor. You can see this, right? Object, then parenthesis, curly braces. So this is basically the default constructor. Now we have another class defined like class bank account, and then there is a bank account constructor, and this is also a default constructor. Now there's another thing, like we have created a savings bank account, which is basically extending the bank account class. So this savings bank account class is a child class of bank account class, and it also has a default constructor. Now what we basically do, we basically go ahead and create a object of the child class. So what it will basically do, it will basically invoke this particular constructor, and then this particular constructor will basically invoke the parent constructor, and then it will go all through. So I'll show you this while I create a demo exercise. So see, constructors in extended classes. If you do not explicitly invoke a superclass constructor, and if the superclass has a no args constructor. No argument constructor is which type of constructor? That is a default constructor, right? If your if the class, if the constructor does not have any argument, so that is basically a default constructor. So what the statement says, if you do not explicitly invoke a superclass constructor, that means you did not create a superclass, you did not create the object of the superclass or the parent class, but what but the parent class has a default constructor. So that will be automatically called when you basically create the child of uh, uh, the object of the child class. So I'll show you this in demo, and then that will be like very clear. So if let's see the second point, if there is no constructor, that means if there is no default constructor in the superclass or the parent class, and the subclass does not explicitly call another constructor of its superclass, and the subclass does not, so suppose there is another parameterized constructor in a parent class, and there is no default constructor assigned in the parent class, then if you create the object of the child class, and if you create the object without any parameters, that will throw an error. Why? Because when it calls the child class, it now goes ahead and sees, it tries to like see whether there is a default constructor in the parent class as well. So at that time, if it does not find a default constructor in the parent class, then it will throw error. I'll show you this through one example, then these things will be like very clear. Then we have like another point in inheritance while instantiating subclass means while creating a object of the child class, its constructor invokes superclass constructor. So it, the constructor of the child class will basically call the constructor of the parent class, and the chain of invocation finally propagated till new args empty body constructor of the object class. See, when we try to like create a object of the child class, what it does, first it calls the constructor of the child class, then it calls the constructor of the parent class, then it further calls the constructor of the, if there is another parent class, and it goes all the way to the object class default constructor, and that is how it reaches there. So the order of execution will be different. So suppose your child class constructor was called first, then parent class constructor, then again another parent class constructor, and then the object class constructor. So the order of execution will be different. Like whatever you have in your object class constructor will be executed first, then the parent class constructor, then the child class constructor, and then if there is any subchild constructor. Let me show you this with an example, then it will be like very clear. So let me try to create let me take an example where we basically have a grandparent, parent, and son relationship. So grandparent will be basically the parent of grandparent will be the super class, and then a parent class will be extending from that, and the son will be another child class which will be extending from the parent class. So let's create a constructor, let's create a class grandfather. Let's create a, so this is a default constructor I have created. Let me print out something in default constructor of grandfather. Let me create another class. Let me create a parent class now. And what we basically want that this is a child class of the grandfather. So let's see the relationship grandfather and then parent. So parent will basically inherit everything that grandfather has. So we'll create a relationship now. So parent extends from grandfather. These things are clear, right? These are like very straightforward, and taking a simple example such that it's like easy to relate as well. Anyone has any issues until now? So I'm creating a default constructor of, sorry, this will be parent, default constructor of parent. Now I will create another class which basically says son, and this son will basically extend from the parent class. And again what I will basically do, I will create a default constructor of son class. So let's go ahead and try to create a tester class. So tester class will basically create to see how these things are working. So let me try to create a object of the sun class. So this is a reference of the this sun is a reference of the object that we created. So when I do this, so when I write out this statement, what happens? So as soon as you have studied about constructor, that whenever we create the object of a constructor, object of a class, the constructor gets automatically called, right? So this constructor will be automatically called when you basically create an object. So since this is this when we created this object, we have provided no parameters. When we provide no parameters, so it will call the default constructor. So it calls this constructor, and now what happens, it will try to see if there is a parent associated to this class. So when the Java compiler sees that the sun class extends from the parent, so it will try to go ahead and see if there is a constructor in the parent class. So it went ahead and saw that this class also has a default constructor. Now it will further see whether this parent class is associated or has a relationship with any other further parent class. So we can see that the parent class is extending from the grandfather. So this grandfather constructor will be now called. So this constructor will be now called. So what happens? First we created the object of the child class, means of the son class. So the constructor of the son class was called, then it further called the constructor of the parent class, and then it further called the constructor of the grandfather, right? Any confusion until now? Hello, everyone there? So what happened? So we created an object of the child class. It called the constructor of this son class. Then further it called the constructor of its parent class, and this further called the constructor of the super class or the further parent class. And what you see, how we got the output. So once everything is invoked, so now the execution will happen. So the execution order will be like the super class will be executed first, and then its child class, and then its child class. So what I basically mean, order of invocation or calling child class, then parent class, then let's say super parent class. So this is the order of invocation, but order of execution will be super parent class, then it will be parent class, and then it will be child class. So what basically happened, your son, when we created the object of the son class, it basically called the constructor of default constructor of this son, and it further went ahead and saw that if there is another parent class associated with it, so we do have a parent.java, so it called the default constructor of this one, and it went ahead and further saw if we have a parent class associated with this, so we have a grandfather class, so it called this constructor, and now the execution starts happening. So now this got executed, and then this got executed. So whatever you have, suppose you have like initialized some things here as well in these default constructors. So in grandfather, first it will be executed or assigned, and whatever print statements you have, now this will be printed in grandfather, and then in parent, and then in son. So basically what happens, the order of invocation or calling is this: child class, parent class, and super parent class, and the order of execution is just the opposite, like super parent class, child class. Try to reflect on this program and let me know if you have understood this or if you have any issues. Okay, so I think I'll go ahead now. What I will basically try to do, I will try to create another object. I will try to create a parent, parent equal to new parent. I am commenting out this particular object now. Can anyone tell me what all print statements will be printed now and in what order?
I think parent and grandfather.
Sorry, parent and?
Grandfather.
So which will be printed first?
First grandfather
First grandfather?
and second parent.
Okay, yeah. Let's try to execute this program. See, what happened now? We basically created an object of the parent class. So it went ahead and called the constructor of the parent class. And then it tried to like check whether we have a whether we have any parent class associated to it. So it went ahead to the grandfather class and it called the constructor of grandfather. So now the execution order is just the opposite. So whatever is there in the grandfather constructor will be executed first, and then whatever is there in the constructor of the parent class will be executed. So let me try to like create another object. What, let me try to comment out this. What will this call?
Only grandfather.
Yes, I think you have got the concept. I think you have got the concept now. So this is it. So the order of invocation is from child class to parent class, and the order of execution will be from the parent class to the child class. Okay, let's go ahead and try to create some of the parameters. I will try to create some parameterized constructors as well. So these were like how we basically call a default constructor. Now let's say we have some attributes associated to the grandfather. Public string name, private string name, and then we have let's try to create a parameterized constructor. I will try to use this technique. Right click, go on generate, try to create an parameterized constructor here. So we are basically taking two parameters like name and age. So these are also instance variables, and I'm creating a parameterized constructor of grandfather. Let me now go ahead and try to create an object of the parameterized constructor. Let's say let me also try to print out something here. So let's try to call this. Let me comment out the previous things. So see, Andy is 70 years old. So when I went ahead and created a object of the grandfather class, so what I'm doing, I'm trying to pass the parameters. Like there are two parameters that it requires, like one is name and then other is age. So this is of string type and this is of integer type. So the Java compiler goes ahead and checks if there is a parameterized constructor of this grandfather. It finds out yes there is. If there was no parent if the grandfather class did not have any parameterized constructor, so we should have got a compile time error. You should have gotten syntax error here itself, but it is there. So these member variables got initialized and we are able to print this. Now let's go ahead and try to let's say I'm creating another attribute in the parent class and I'm trying to generate. Okay, let me just create it this way. Public parent, let's say double salary. This dot salary is equal to salary. And I'll create another parameterized constructor in the sun class. So let's say public sun. Okay, let's define some attribute. Let's say how many number of toys this sun has. Let's try to print out certain things as well. So let's see what we did just now. We basically created three parameterized constructors and initialized some data members in each class. We created like name and age in the grandfather class, and then we created a parameterized constructor. Similarly, we went ahead, created an attribute salary, and then created a parameterized constructor. And then similarly in the son class as well, we created another attribute number of toys, and we created a parameterized constructor. So let's see, we'll comment out all previous objects. We'll try to create a, and let's pass some of the
Right.
values. So this was expecting an integer value for the number of toys. What do you think this will print?
Number of toys 10.
Uh, what will this print? Number of toys, is it?
10.
Do you think it will print anything else as well? Everyone try to think on this. Will this print something else as well? Or will it just print number of toys colon 10? Okay, let me try to go. Yeah, anyone has any clue about this? Okay, let me try to execute this. See, what it basically did, when we went ahead and called this parameterized constructor, so it went ahead and called this parameterized constructor. Since we did not call a default constructor, so at line number 5, when we were calling a default constructor with no parameters, what it was doing, it was calling this constructor, right? Default constructor. Now we are passing a parameter. We are passing a parameter, and so that is why it is basically going and calling this constructor. But what happens if we do not call the uh, another constructor, if we do not call the parent class constructor from here? So it will try to go ahead and try to see if there is a default constructor in the parent. So there is a default constructor in the parent, and then it further sees whether this parent class has got another parent which has a default constructor. So we have this grandfather class which has another default constructor. So it calls this constructor as well. So the order of execution will be just the opposite. This constructor got called first, right? Then it further called this constructor, and then it further called this constructor. So what will be printed first? This will be printed first because the order of calling and the order of execution are just opposite. So this will be printed first, then this will be printed, and then this will be printed. Now let me make some twist. Let me make some twist here. Let me try to think that I don't want that this constructor gets called. I don't want that this constructor gets called, the default constructor of the parent class. So what can I do? Can I do something about it? Okay, let's think on this. So Java has provided something, a keyword called super. So what basically super does is this will try to call the constructor of the parent class. It will try to call the constructor of the parent class. So if I just provide a super like this without any parameters, so it will call the default constructor, which we basically don't want because this was already getting called. So when I write a keyword super, it will try to see if there is any argument provided to this. So as of now, we have not provided any argument over here. So this will go ahead and call the default constructor of the parent class. But let's say we want some, we pass some salary over here. Let's say we pass salary as 2000. And now what I will do, I will try to execute this particular constructor. What do you think will be the output now? So this one thing, this super keyword, right? It calls the constructor of the parent class. So I'll just write it down. Super is calling parameterized constructor of parent class. And also there is one important thing to note. Super must be the first statement within a constructor. So what that means is if I try to write this super here, see suddenly I started getting a syntax error, right? So this super will always be the first statement in a constructor. Whenever I create a constructor and try to call the parent constructors, this super must be the first statement in the constructor. So let me try to execute now. Can anyone guess like what will be the output now?
Let me try.
So,
Default constructor grandfather, and for the parent is 2000 and the number of toys 10 for soon.
So you're
yeah,
saying
200.
first this will get printed, right?
Yeah, it's a 200 already changed. That's okay.
And then this will
And
get
then
printed, and then this will get printed. Is it what you're saying?
yeah, I'm saying the grandfather just already at 200, right? 2000.
Okay, let me try to execute this. I'll show
That
you.
is for parent.
Let's see what this will execute. See what it did now. So now basically when I called this parameterized constructor, so when I called this parameterized constructor, right? So it called this particular constructor. It will not call the default constructor because we have already passed a parameter with number of toys. So we went ahead and called this constructor. And as soon as we saw this line number 10, as soon as we saw this line number 10, so what it basically did, it basically called the constructor of the parent class. And which constructor will it call? It will call the parameterized constructor, since we are passing the parameter. So it will basically go ahead and try to call this constructor. And then once it is here, it will further see if there is any parent class associated with it. So there's a parent class called grandfather, and it will try to see if there is a default constructor associated to it. So there is a default constructor. So it calls this. So first this gets printed, then this gets printed, and then this gets printed. Got it? Now let me try to see, let me try to like make other edits as well. I don't want to call the default constructor of the grandfather. So what should I basically do? I don't want to call this default constructor of the grandfather. Can anyone tell me, can anyone write out the simple line of code in this parent.java?
Hmm.
Okay, from inside, yeah, that is, we can super
Yes.
name
So let me pass some name over here,
mhm,
and then we pass the age, right?
age. Mhm.
So let me see what it will do now. So let me try to run this again. So see,
Let's change it. Yeah.
so now the default constructor of the parent is of the grandfather is not called. Why? Because when we call this, when we are calling this, it calls this parameterized constructor, and there is a super. So there's a super with a parameter. So it will basically call the parent, and then there is another super. So this will go ahead and call this grandfather parameterized constructor, and the order of execution will be just opposite. Grandfather will be printed first, then parent will be printed first, and son will be printed first. Son will be printed thereafter. So everyone got the concept, right? How we basically call a constructor, and how the parent class constructors are called, how the default parent class constructors are called, and when we don't want to call a uh, parent class default constructor, so we basically provide a keyword super and provide the parameter, so, such that the parameterized constructor of the parent class is called. And further in the parent class parameterized constructor, we again pass this super keyword with this parameter. So it went ahead and called the parameterized constructor of the grandfather. Any doubts, anyone? Because this is a
Yeah,
very important concept. If anyone has any doubts, you can ask now.
yeah. From the grandfather parameter constructor, can we pass from the zone?
Sorry, I did not get
Yeah, can,
from.
can you go to parent
Yes.
and also number 10, line number 10? Can you cut it? Yeah, cut.
Do you want me to comment this?
Yeah, and also can we use from the zone parameter constructor?
Do you want me to comment this?
No, no comment, no comment, no
Okay.
comment. Without comment. So before this,
You wanna add?
can we write super? Yeah, yeah. No, no, no. From this,
Okay.
in between line 9 and 10,
Okay.
super.
Super.
Uh, uh, can we pass name? One of name, Mike.
Okay.
not salary. Why you coming salary, Mike?
Okay.
Yeah, and
I-
passing it to age.
Okay. Okay. One thing, like super can never be the second line in a constructor. So if you have two supers, this super is the second line in a constructor. So this will throw error. Let me comment out this one. So now see what this will do. Son is a descendant of the parent, means its immediate parent class is this parent and not the grandfather one, right? Got it? So when you pass a super Mike 45, right? So it will try to search this kind of constructor in this class, in the parent class. So it will not get this type of constructor, right? So that's why you are getting an error. So when you do something like super Mike 45, it tries to go ahead and in the parent class it will try to search if there is a parameterized constructor with a string value and an integer value. So it does not find out any constructor like that. So that's why this will throw you an error. Got it, Gaso?
Yeah. Correct.
Okay. Anyone still has any doubts, you can ask. This is because this is very important topic, and this will help you in basically understanding what in order of invocation you can apply. Okay, there's also one more thing that I would like to show you. Okay, this is one thing, constructors. Let me close everything here. Let me try to like create another Java class, and let me try to create um, a student class, and I will create some attributes. Let's say the student has an ID, the student has a name, the student has got some marks in the exam, and let's say the student studies some some number of subjects. Say the student studies say 5 subjects. Now what I'm trying to do, let me try to create constructor. One will be a default constructor, and in this default constructor I'm just printing out a default constructor. Let me try to go ahead and create a parameterized constructor. Generate constructor id name. So I just took out 2 parameters and generated one constructor. Let me go ahead and try to generate another constructor, and this time I'm taking these 2 parameters and generating another constructor. Now let's create another main method. So in this main method, basically I'll go ahead and create the objects of this student class. So what I will basically do, I will create a object of the student class. I'll pass out some parameters. Let's say I'll pass out marks as 450 and the number of subjects as 5. Let's say average of m- average of marks secured. What this will be? This will be basically total marks by number of subjects. Let me just try to print out something similar to like this. So what is expected now? When I run this program and create this object, right? So it will try to search for a constructor in this class which has two parameters, like which has two parameters which takes integer parameters and calls this constructor, right? So average of marks secured 90, right? So anyone has any issues with this? So this is fine. Now what I basically do, I will try to use something like this. I will try out this and then I will try to call this. So when I try to run this, so what it will basically do, everyone remembered, right? This was used to call the constructor of the same class. So when I just pass this, let me try to go ahead and execute this. So what it basically does, it basically goes ahead and calls this particular default constructor. So why default constructor? So this, we have not passed any parameters over here. So see, I'll write it down. This keyword calls the constructor of the same class in which it is defined. See, super had a different function. Super was basically calling the constructor of the parent class, but this is this keyword basically calls the constructor of the same class in which it is defined. So it went ahead and tried to see if there was a constructor which had no parameters. And also one more thing, this also, this must be the first line in the constructor. This must be the first line in a constructor. So wherever you uh, whenever you create this in a constructor, this has to be the first line. So now let's go ahead and try to see if we can do something like this. See, we started getting an error, right? See, call to this, just see this error. Call to this must be the first statement in a constructor body. So it's expected that whatever, whenever we write a this or a super, that must be the first statement in the constructor body. So let me try to go ahead and comment this. Let me comment this out. So now when I pass these two parameters, and let me try to like print out something. So let me try to print out this. See what happened now when I created an object of the student class and tried to pass marks and number of subjects. So the two data types were integer types, and when I passed the parameters as integers, it basically went ahead and called this particular constructor. And when it came to this constructor, it goes to this particular line and it sees that there is further another call to the constructor of the same class, and in the and when I call this, I'm basically passing two parameters, that is one is integer and the other is a string type. So the Java compiler tries to search for a constructor which has similar arguments. So this constructor at line number 14 basically has two parameters, one is of integer type and the other is of string type. So now this gets called. So the order of calling was this constructor was first called and then this constructor was called, but the order of execution will be just the reverse. So whatever is written here will be printed first and whatever is written here will be printed next. Any doubts about this? You can ask. Everyone understood this concept? Okay, we'll go ahead and see the slides now. So, see, we have seen this, whatever points were defined here, we have seen this. So, we have created constructors in the extended classes, and then we had tried to call parent class, constructor class, parent class, child class, and so on. And next, we had seen the usage of super as well. We had used super to call the parameterized constructors of the uh, parent class. Also, with the help of super, we can call the default constructor of the parent class. And then we also went ahead and saw one example where we were basically trying to call a call the constructor of the same class using this keyword. So if we don't pass any parameter using the this keyword, it calls the default constructor, and if we pass any parameter, it basically tries to call that constructor which has similar parameters. So this was invoking constructor using this keyword. So just see this. A constructor can also call another constructor of its own class by using keyword this. Such type of constructor invocation is called as explicit constructor invocation. The this keyword refers to the current invoking object. In the above code, the statement this amount false will call the constructor of the savings account class, which accepts two arguments, that is float and boolean. So I have shown you this example with the student class. So if there is no doubts until now, we'll start with another topic. Okay, let's start with another topic now. Okay, so let's start with another object oriented principle. This is polymorphism. So what polymorphism means basically is having many forms. So it is like polymorphism is the ability of a message to be displayed in more than one form. So basically one particular thing has a has lot of different forms. So you can relate something like this. Real life illustration of polymorphism is something like a person at the same time can have different characteristics, like Like a man at the same time can be a father, he can be a husband as well, he can be an employee as well. So it's just one person, right? But he is like having different relationships. So at the same time, he's a father, he might be a husband, he might be a son to his father, and he might be an employee in some company. So it's about the same person, but he has like got many forms. So it comes from some Latin word where poly means like many and morphism means forms. So it's like many forms. So what is basically polymorphism in Java? Polymorphism is considered one of the object-oriented principles. So polymorphism allows us to perform a single action in different ways. So in other words, polymorphism allows you to define one interface and have multiple implementations. The word poly means many and morphs means forms. So it means many forms. So what are the type of Java polymorphism? So in Java, polymorphism is mainly divided into two types. One is compile time polymorphism and one is runtime polymorphism. So we had already seen this method overloading, right? We had seen the concept of method overloading earlier when we tried to create a product class and also an addition class, and we were trying to perform the addition for different number of arguments and different data types. Anyone remembers that we had done the method overloading? Let me try to like just show you a glimpse of those examples as well. Okay, let's see this example where we had uh, created calculate product method, and then there was another method which was like calculate product, and we were overloading this method. So this was like overloading of methods, and the first method was basically computing the product of two integer numbers, and the second method was basically computing the product of two double numbers. So we had seen this example, and based upon the parameters that we pass during object in or during method invocation, suppose we passed two double variables here, so it will go ahead and call this particular method. When we pass two integer numbers, so it goes ahead and tries to call that method which has two integer parameters. So this was the concept of method overloading. This is also called compile time polymorphism. So we'll see today, we'll see overriding or runtime polymorphism. So let me try to go ahead and create another package called overriding.method. So let's see. A subclass can replace its superclass implementation of a method with one of its own. This is known as overriding a method. So suppose you have some method in your parent class and you have the same method defined in your child class as well. So child class is also called a subclass. So what will happen? A subclass can replace its superclass implementation of a method with one of its own. This is also called overriding a method. So whatever implementation was there in the superclass method, you are basically overriding that with some another implementation in your child class. So this is called as method overriding. So there are some rules for method overriding. Name and signature of the method must be same. So like in method overloading as well, right? We had the name and signature. Uh, But what was different in method overloading? The number of parameters can be different and the data type of the parameters can be different. But in method overriding, the signature of the method must be exactly same. The data type also must be exactly same. So let's see another point. Return type may be same or polymorphically compatible. So what this means is the return type of the methods. Suppose there's one superclass method and then there's a child class method. So it has some return type, right? So the return type should be compatible if not the same. So that is what second point is about. And third point, the scope of overridden method should be the same or can be made expandable. That is, the visibility of the method cannot be reduced. So this means that we have seen some access specifiers or access modifiers, right? So when I say about access modifiers, we have talked about private, protected, default, and public. We have seen these demos as well, right? So what these keywords basically do, they basically restrict the usage of some of the variables or methods in some class. Basically, these access modifiers are used to show visibility of a method or the variables. So what this third point basically tells is the scope of overridden method should be the same or can be made expandable. That is, the visibility of the method cannot be reduced. So suppose private has the least visibility, then default has more visibility than private, and then comes protected. So protected has more visibility than default, and then comes public. So public has the highest visibility. So if you just go and revise your access modifiers class, you will get to see the demos. So private has the least visibility, that is, the access is restricted to only within the same class, and then comes default. So default has access at package level. So whatever classes are there in the package can access the methods or variables defined in a class within the same package. So that is the scope of default. So when I talk about protected, so the access or the visibility of a protected is basically within the same package, and if it is like in the other package, then that class has to be a subclass of the parent class in the other package. So that is the scope of protected. And when I talk about public, the scope is public means it's like accessible anywhere, whether in this package or in the other package. If some other class is like using it, so the public has like the highest visibility means it's like it can be like visible across packages. So that is the scope of visibility. I had already shown you this demo using all those access specifiers. So what third point basically tells is, if a method is private, if suppose if a method is default, so default method should be like and if you are trying to like override it in a child class, so the visibility should not be lesser than default, it can be like greater than default only. So that is what we mean to say. So point number 4 is the overreturn method can choose to either throw exception or same exception or polymorphically compatible exception with the superclass. So if there is some exception thrown by the parent class, the child class should also be throwing the same exception or some compatible exception. So we'll not see this particular point as of now because we have not studied like exception handling. Whenever we go ahead and study exception handling, then we'll see this point. But all other points we'll see now. So see, overriding methods. What this class is basically doing, it has some a protected instance variables like current balance and name, and then you have a constructor which basically takes two parameters for uh, assigning name and current balance, and then you have a method, print method, where we are basically printing out the name and current balance, and we are overriding these methods here. We have a child class called a savings bank account, which is basically extending the bank account, and so we are creating another print method here. So see, we are creating another print method here. Let's say this super dot print is commented out as of now, and we are printing out this one. So when we go ahead and try to create the object of the child class, what it does, it tries to do a essay dot print. So when we do essay dot print, it will try to search for the print method in the same class first. So if it finds out something here, so it will basically try to call the method of the child class. Let me try to show this with an example. So there is another current account class, and there might be another classes as well. So we'll see this with an example, then it will be like more clear. Let's say we create some, let's say we create the bank account class again, and then we have something else. Let's say so I'm basically creating a constructor and initializing these variables. Now what I'm basically doing, I'm trying to create one print method. Let me print out this. I'm trying to print out the name and current balance. Okay, so this is one method. So now let me try to go ahead and try to create a savings bank account class. So savings bank account will be a child class of the bank account class, and that is why this will extend this bank account class. So this is giving me some suggestion, since we have created a child class. It is giving me some suggestion that we need to create this constructor. So let me try to create another print method. Basically, our agenda is that the print method that we have here, we want to override this behavior with this print method. So let's also create one more variable. We'll try to check if this is our salary account as well. And we'll do something like this dot is salary account is salary account. So remember this example, right? What this basically super current balance and name will do, this will basically go ahead and call the this will basically go ahead and call the constructor of the parameterized parameterized constructor of the parent class. Remember we have seen this example just now.
Yes.
Yeah, so this is another print method that I have created. Now let me go ahead and try to create a main method. In this main method, I will go ahead and try to create a object of the child class. And I will try to pass three parameters here. Let's say I passed the current balance, name, and suppose this savings bank account is also Jordan's salary account. Means Jordan gets his salary in this particular account. Okay, why am I getting an error here? Okay, no parameters. Expected 0 but 3 arguments found. Okay, okay. Sorry. Savings bank account. Actually, it imported some other savings bank account that was like created in some other package. That is why we were getting that error. Okay, so now we have this object created of the child class and we are passing three parameters, that is current balance, name, and salary account is true. That means this is Jordan's salary account and he has a current balance of 2000 rupees. So what we'll do next is we'll try to call super dot print. So we will try to print something like this in child class method, and we'll also try to sprint something here like in parent class method. So let me go and try to run this now. See, what we are basically seeing, it is printing in child class method name Jordan, current balance equal to this. See, earlier, let me try to also do one thing. Let me try to go ahead and comment this out. So when I comment this out, let me try to run this now. What it prints now? It prints in parent class method name Jordan, current balance 2000. Remember this, right? When we were learning inheritance, when we had studied inheritance, we saw this example that we created one method like that deposit, withdraw and get current balance example, right? We created some method in the parent class and then we were able to call it with the object of the child class, even if this print method I've commented. So this is not defined here, right? Let's just delete it. So we don't have the print method defined here, but using the object of the child class, we can still call this. Remember, this was the concept of inheritance. So we are still able to call this because our child class is inheriting the methods from the or behaviors from the parent class. So this was one thing. Now what I'm basically doing, I am I'm just overriding that method. I'm just overriding the method with the same signature, means the name is exactly same, the return type is exactly same. So this method is overridden method.
Yeah,
Over,
can you execute this?
yeah, I will execute this overridden method. So this is an overridden method. So when you have the same signature both in the parent class and in the child class, so it will basically try to find the method in the child class. So now the expected output will be in child class method and the name Jordan and current balance 2000. Let me try to go ahead and execute this. See, in child class method name Jordan, current balance 2000. So this is it. Now what I want to do, I want to basically try to explicitly, if I want that, I want to call the method of the parent class as well. If I want to call the print method of the parent class as well. So there is another way. We can do a super and then I can call a print. When I do this, and remember, whenever super is used, it basically is the first statement. We saw the usage of super while invoking constructors, and in a method as well, when we use super, this should be the first statement in a method. So now let's go ahead and call this. So see what it first did. When we try to call this savings account dot print, it went ahead and called this print method. But at line number 15, it basically saw that we are trying to explicitly call the print method of the parent class as well. So it went ahead and called this particular method. And again, the order of calling and the order of execution will be just the opposite. So the order of calling was first this method was called and then this method was called. And so what will be printed first? Execution will be first. This statements will be executed within this print method, and then this statements will be executed in this print method. So this is how you can explicitly call a parent class method as well. So this is explicitly calling parent class print method. So this is how you can basically override the methods, and this is how you can explicitly call parent class print method as well. So this was about this was about method overriding. So this is also called as runtime polymorphism. So in interviews you might be asked certain questions like, what is the basic difference between runtime polymorphism or compile time polymorphism? So you can demonstrate the examples that runtime polymorphism can be basically achieved at runtime. And why at runtime? Because when we call the methods, so at runtime basically the object reference decides which method to basically call, whether the method of the parent class or the method of the child class. And if there is some reference, if there is some super dot method of the previous parent class, so that is uh, also called. So that is decided at runtime which method will be basically called. And similarly you have compile time polymorphism, that is basically achieved by method overloading. Method overloading, we have already seen the example of the product class and the addition class, where we were trying to like use the same overloaded method with different data types of parameters or the different number of parameters. So this was about method overriding. Any doubts in this one?
Parita, the line number 9, I expected the execution result before explicitly calling. So both of, because we use number 9 and into line 9, super current balance and name.
Okay,
So
so
why we use again
so
the
do
explicitly
do you
calling.
want me to like comment out something or like
Yeah, what's the function of the first super?
okay, see the super at line number 9 you are speaking, right?
Yes.
Okay, see what happens. Okay, I'll write down some print statements, then it will be like more clear. I think I did not write out anything in the constructor, so that is why. Okay, let me write out some comments in this. In parent class constructor, and then we'll write out something like this here. In child class constructor. So when this object was basically created, so this is child class object, agree with me? This is a
Yes. Yeah.
child class object. So it will go ahead and create and call this particular constructor, right? So at line number 9, what happens? It sees that there's a super keyword and we are passing two parameters. So basically this will try to call the parent class constructor and the parent class parameterized constructor. So it goes ahead and tries to call this particular constructor and it initializes the data members, current balance and name. And now this particular constructor was invoked, so the order of execution will be first this a constructor will be executed and then this constructor will be executed. So let me try to run it now. See, this was what we were seeing in constructor invocation as well, right? So this got executed first in parent class constructor and then this got executed in child class constructor. Now at line number 23 we are basically calling the print method. We are calling the print method of the uh, we are calling the print method. So what we'll basically do is this will go ahead and try to see if there is a print method in the child class. So we see that there's a print method in the child class. So it goes ahead and tries to see if what statements are there. So it finds that there is a super dot print as well. So this super dot print will basically go ahead in the parent class and try to call the print method of the parent class. So it went ahead here and called this method. So the order of execution will be now this will be executed first, and then the Java compiler will come here and then call this method. So see, there were two things in this example. When we created an object of the child class, it went ahead and called the constructor of the child class. Then it found this super. Using this super, it called the constructor of the parent class, and the order of execution will be now this constructor will be called now, executed now, and then whatever is written in this constructor, child constructor, will be called. Similarly, when we are calling a method, it will try to first call this method, then there is a super dot print. Using this super dot print, it goes ahead and calls this particular method, and whatever is here in this particular print method will be executed, and then the control will come to this print method, and whatever is there in the child class print method will be printed. Do you have any doubts now as well? Hello, is your doubt clear? Okay, okay, we'll see some more things in method overriding. Let's do one more thing. Let's try to create a static method. Okay, we'll see some more things. Let's make a class as default, void get data. So see, if there is no access modifier, it means that this is default, right? You remember this? This is default. So, or let's make it public. Public, and try to in get data of parent class. Now see, this was public void get data, and let me try to keep this as default. See, when I'm trying to keep this as default, what error I'm getting? See, get data was public in the parent class, but it is default. Remember the visibility thing I told you? Remember the visibility thing that I told you? If we are overriding a method, if we are overriding a method, then the visibility of that method must be either same, either this has to be public. In this case, this definitely needs to be public because public is the highest visibility. So if we try to like make this public, then this error will go away. Remember the visibility principle? Now this error will go away. So the visibility cannot reduce. Let's say we make this as protected. We are making this method as protected, and this is public in the child class. This get data method is public in the child class. So this is allowed. This is allowed. Why? Because the visibility of a method when it is public is more than the visibility of a method when it is protected. So let me just write down the comment here. Visibility of overridden get data method must be same or more than that in the parent class. Is this point clear? Is this point clear to everyone? If you remember the access modifiers and the visibility order of visibility, this will be very clear. See, a protected method can be overridden using a public specifier. A default method, even if we like make this as default, let's make this as default. Even then, this is fine because the visibility of public is more than that of default, right? So this is fine. This is perfectly fine. But it's not the other way around. If I make this as protected and if I make this as public in the parent class, this will start giving me compile time error because an overriding method in a child class must definitely have its visibility more or equal to whatever the visibility was there in the parent class. So this is about another rule about visibility of an overriding method. Let's see one more example. Let's try to create a static method here. Static static print data. Static void print data. And let me try to static method call. Now let me try to find the same thing here. Static method call in parent class. Static method call in child class. And let me, how do we basically call static methods? Let me try to call the static method. See, this is a static method and this is another static method. So this can be simply called this way. So let me try to call this. So this will basically call this particular method. Static method call in child class. Now see, this super.print data will not be available. Why? Because static methods are not overridden. Even if you remove this static method here, right? It does not matter. It does not matter. You have two static methods in each of the class, in your parent class, in your child class. So the behavior of static methods is that this cannot be overridden. So even if you like remove that method or have this method, this will have the same effect because it will always call the child class method only. It will never call the parent class method because static methods are never overridden. This is like the simple invocation or simple calling which we used to do earlier. So don't get confused about it. Now let's go ahead and see some more examples in the we'll come and see
You
some more
mean
yeah.
print date data means it just indicates for order or what is that?
Sorry, can you please
Print,
speak a bit louder?
yeah, print data.
Print data, yeah.
The last time you print is for order. Yes, last one. Yeah, when you put on the top, you can change some order.
You want me to put this here?
The top. Yeah, can you change it to some value?
Do you want me to run this?
Mm-hmm.
Okay, this will be like again same. This will be like printed first static method call in the child class. See, this is a independent method call. This has nothing to do with your this object creation or this method invocation. So this method call is basically independent. So when I say this print data, it will go ahead and try to see if there is a static method already existing in this class. So this is a static method. See, static methods can be simply called using uh, the class name, right? Because when we even without a class name, when we say something is static, that is like it is related to the class and it is available throughout the class. So this print data method is available throughout the class. So this method can be basically called by a static method or by any non-static method. So that is what it is. So when I say print data, see, this is a static method. This can be called by static method. So it simply prints out this one. Got it?
Yeah, I got it. But yeah, the changes. I mean the order, right? I'll print the order.
So
Not
printing order will be like, see, there is nothing that we are basically doing. So this will be printed first. Why? Because this is getting called.
okay.
See, when we print data, only this block of code got called, right? It has nothing to do with your constructor or this print method because this there was like concept of inheritance and overriding in these things, right? But
Mm.
in this static method, right? Static methods are never overridden. I will write it down as well here. So this is an independent called static methods are not overridden. So this is an independent call. You forget about all this. So when you do a print data, it goes ahead and sees if there is a static method. Why? Because we are not using an object to call this. When we are not using an object to call this, so it means that we are calling some static method only. When we used to call these methods, right, we used to create object and then call, right? Why? Because
Mhm.
these are non-static methods. Remember the rule that a non-static method or an instance method will be called using an object, but a static method can be simply called in a static method. If it is in the same class, it can be simply called with the method name. If it is in a different class, we can basically call with the class name dot method. Got it?
Yep. Thank you.
Okay. Okay. Let's see some more examples. Okay, we have seen this like how we basically use super to call a constructor, how we basically use super to call a parent class method, and the concept of overriding also we had demonstrated. So let's see some more things. Making methods and classes as final. So when I say the word final, the final can be used with all the three things. Like final can be used with classes, it can be used with fields, it can also be used with methods. So When we make a class as final, so what that means is we are declaring a class as final, and any final class cannot be extended by any other class. So we have created one parent class and we made that class as like final, and we are trying to use a child class to extend that final class. Suppose say we have a final class grandfather, and then we created a parent class like parent class parent extends grandfather. If you try to do something like that, it will basically throw error. Why? Because final keyword, whenever we use a final with any class name, right? So it basically restricts that we cannot override or inherit that particular class. We cannot inherit that class. So when you want some class to be final, so there might be certain use cases like for security purpose you have created some class and you don't want that your code might be called from anywhere, such that you don't want that particular class to be modified by any other place. There are some places where you might need such particular code that it's not modified by any object calling or any uh, modification as such. So in that case what you will basically do, you will make that class as final, so you cannot inherit that particular class. It cannot be extended by any other class. Got it? An entire class when declared final cannot be extended by any other class. All the methods of a final class are implicitly final. So this means that declaring a class as final prevents inheritance. So your child class basically cannot extend any final class. So inheritance is not allowed when a class is termed as final. Now what happens when you use a final keyword with methods? So suppose before your method, suppose you had a void display method, and before that you are putting a final keyword. So when you use the final keyword before any method, you are basically preventing that method from being overridden. So any final methods will not be overridden by a child class. You can prevent subclass from overriding the implementation of a method of a superclass by making it final. For example, you may want to ensure that no matter which class overrides the linked list class. Okay, we'll see about this linked list class when we study collections topic. So let's not get into this linked list. Means that is some data structure that we'll see when we study the topic collections. But understand that when you make any method as final, you are basically preventing that particular method from being overridden, such that that particular behavior of the method in the parent class cannot be overridden by the same method signature in the child class. So that is preventing the method overriding. Now when you mark any variable as final, so when you mark any variable as final, so it basically becomes a constant. So what I mean by constant, that's that value cannot be basically changed. Let's just see a quick demo about it. Let's try to make final integer, and let me take one id and try to make it as 100. Now when I try to like see what I am trying to do now, non-static field id. Okay, this is okay. Let's make this static. See why we were getting that error is this was a non-static variable. Remember one more thing, non-static variable cannot be accessed from a static method. Opposite is true, like static methods can be called from anywhere. Static methods and variables can be called from non-static method as well and static method as well. But a non-static variable or non-static method cannot be called from a static method. So let's see, we have made this value as final static anti id. Now what I'm basically doing, I'm trying to modify that value, but this is giving me error, right? Why this is giving me error is cannot assign a value to final variable id. So cannot assign a value to a final variable id because this is constant. This cannot be modified. Got it? This is when we are basically using a final with this variable. So it makes it as constant. The value of this variable cannot be changed throughout the class. Now let's try to do one more thing. Let's try to create, see, I'd created a final void parent class method, and I created the same method here. When we see other examples, right, this was allowed, we were able to override this, but as soon as we made the method as final, we started getting error, right? See what it is basically saying, parent class method cannot override parent class method in the child class because overridden method is final. So this will be basically prevented. So we are getting an error. So I'll just write down a comment here. Final methods can't be overridden. And when I try to make this entire class itself as final, public final class bank account. See, we started getting an error in the child class. Cannot inherit from final class because this is a your parent class is final, so that class cannot be inherited. Got it? So there are basically three uses of final. You can use it with variables, you can use it with methods, you can use it with the class. When using with variables, you are basically making that variable as a constant. That value of that variable cannot be modified throughout the class. When you are basically using variables with a method, you are restricting that method from being overridden in a child class. When you are using final with a class name, you are restricting that class from getting inherited. So this is about final. If you have any doubts about this final, you can let me know. We'll stop our uh, uh, today's class with this topic only. If you have any doubts with today's class, you can let me know, or else we'll conclude the call. I'm stopping the recording.